Now here, man. Suppose we have a resistor is connected to C in AC, and resistor is connected in AC. What will happen? Is the current? What happens to the current here? Okay.
So it alternates.
So they are in series, they are in phase or they are out of phase. Like suppose this is the input voltage. Okay, V is equal to Vm sin omega. Okay. So what will happen? They will be in phase. Okay, the current and this is the current. Current is equal to Im sin omega. They both are in phase with each other. Okay, current and voltage both are in phase with each other. When we connect a resistor in AC. Clear? So what will happen if you are drawing a phasor diagram? The phasor, this is the phasor diagram. This is I and this is V. Is that clear? And this is the omega t. We can write phi is equal to here.
Yes.
Is that clear? This is how it works. And we are writing V is equal to Vm sin omega t, I is equal to Im sin omega t. Now for capacitor, suppose inductor, capacitor, second was inductor, right? So if you are connecting here what happened? Here the resistor is connected to AC. Okay, sorry. In this case, the resistor was connected in AC. Now, second case, what happens? In inductor, what happens here? This is the AC circuit, and then here the inductor is connected to AC. Okay, inductor is connected to this. Then what will happen now? In this case, who is leading and who is lagging? Yes, can you tell me? Who is leading and who is lagging?
So the second one is leading. So what do those two lines mean?
One is voltage line, one is current line. This is the inductor. This is inductor. Okay.
Okay, sir.
Whole thing is inductor. What will happen now? When I connect a voltage in inductor in AC, what will happen? Yes.
So it will become slower, right?
Yeah. So it will lag, right?
It will lag.
It will be lagging by 90 degrees. Okay. So it will lag by 90 degrees. Okay. So this is voltage line and this is the current line. Okay. So they both will lag by 90 degrees. Is that clear? Is that clear?
Yes, sir.
So here,
yes, sir.
what will happen? Current lags voltage by how many degrees? 5 by 2. That is 90 degrees. Okay. Now suppose. Now what will happen now? So here what will happen is this is the voltage and this is the current. Okay. So this is the current. So angle between both of them is how much? Omega. Is that clear? Angle between both of them is 90 degrees and this 90 degrees and this angle is said to be omega. This angle is said to be omega. Is that clear now? Is that clear? See why it is, what is happening exactly? See, we will see for one cycle. Okay, we discussed that also in the previous class. For one cycle, what will happen for a one cycle? Like suppose this is one cycle. A, B, C, D, and E. Okay. Now A to B is quarter of a cycle. Okay, quarter cycle. A to B is quarter cycle, B to is quarter cycle, C to D is quarter cycle, and D to is quarter cycle, which makes one complete cycle. Now, what will happen when for A to B, the energy is absorbed. The energy is absorbed by the inductor. What is an inductor? Inductor is a component which stores magnetic energy. Understood? Inductor is a component which stores magnetic energy in the form of magnetic field. Understood? Inductor is a component which stores magnetic energy in the form of magnetic field. Now what happens from A to B? There are four parts of a cycle. From A to B, what is happening? The energy will be absorbed by this one. It starts magnetizing. The magnetic flux starts set up in the inductor. Magnetic flux will set up in the solenoid, or this is solenoid or inductor. Now what happens? So that is why it is at it is at negative here. Now what will happen?
Yes, sir, what does inductor stores magnetic energy in the form of?
One second. Yeah, what happened? Tell me.
So inductor stores magnetic energy in the form of what?
Magnetic field. In the
Okay,
form
so
of magnetic field. Okay. So what will happen for A to B? The magnetic field will set up and then it starts magnetizing, and the magnetic energy is absorbed. The energy is being absorbed. Then what happens from B to C? It starts demagnetizing. From B to C. When it is from B to C, it starts the inductor starts demagnetizing, and the flux will become zero, and the energy is released. Is that clear? The energy is being released. From C to D, what will happen? From C to D, again the magnetic energy is absorbed. Okay. From C to D, again the magnetic energy is absorbed. And what will happen? Again, it starts magnetizing, but it starts magnetizing in the opposite direction, not in the same direction. It starts magnetizing in the opposite direction. Is that clear? Again, the magnetic field will set up in the solenoid or in the inductor. From D to E, what will happen? Again, the energy is released. Again, the energy is released. Okay, and it starts, the magnetic setup will become zero, and energy is being released, and it starts demagnetizing. Okay, where all it is demagnetizing? From B to C and D to E, it will demagnetize. A to B and C to D, it will magnetize. Understood now? So this thing will happen when the inductor is connected in AC. Is it clear?
so can you explain the last part again?
See here, from A to B and C to D, it will magnetize. B
Yes,
to
sir.
C and D to E, it will demagnetize. Is that clear?
Okay, sir.
Uh,
Yes,
that,
sir.
that is the thing, it will happen. Now, chalo. Next, I am connecting inductor to the capacitor to AC. What is the purpose of a capacitor? The purpose of a capacitor is to store
Store
electric energy in the form of electric field. So
electric
a new
energy.
component has come into picture. XL is equal to what? Omega into it. What is XL? XL is the inductive reactance. XL is said to be inductive. What is reactance? Now, suppose I can compare, as I told you, inductive reactance. So, as I told you previously, like we can add or subtract similar physical quantities. Understood? We can add or subtract similar physical quantities. So, in that case, what will happen? XL is equal to omega L. What is happening now? So, there is some reactance law, or we say impulse response. So, when you apply AC, when you connect this inductor in an AC, what will happen when the pulse enters? So it starts opposing. Who? The inductor starts opposing. When something is sharp, something is flying towards you close your eye. That means there is a response given by the eye. That is said to be impulse response. Same thing will happen when you apply the voltage for across the inductor. What will happen? It starts opposing in the beginning. Means that is inductive reactance. Like suppose you want to put some eye drop in your eye, you will not allow your eye to open, is it not? So same thing will happen. That is said to be inductive reactance or impulse response. So that omega XL is equal to what? That reactance or the resistance offered by the inductor is known as inductive reactance. We cannot say resistance, so instead of saying resistance, we are saying inductive reactance. Okay, that means resistance offered by an inductor is known as inductive reactance. Is this clear, all of you? Yeah.
Yes, sir.
Now going with the next one, the third one. Okay, the third one, that is a capacitor. Okay, the third one, that is a capacitor. So now, so when the capacitor is connected in AC, what will happen now? So this is the capacitor in an AC. So what will happen? Now we will draw the cycle first. This is the voltage cycle. Okay, and this is V. And what happens to I? What happens to this one? The capacitor will starts. It will become maximum in the beginning. It comes down like this. Okay, it comes down like this. Okay, so this is the thing which happens for the capacitor. So this is voltage and this is the current. Okay, sorry, voltage and current is, this is the current. Now what happens, the here current is leading voltage by how many degrees? 90 degrees. Okay, this is the voltage and this is the current. Okay, and there is a 90 degrees between both of them. Who is leading here? Current is leading the voltage. There what happened? Current is lagging. I is lagging. Okay, current is lagging, voltage by how many degrees? By 90 degrees. Okay, by 5. Is that clear? Now here what happens? Voltage here, current is leading the voltage by 90 degrees. Is that clear? Current is leading the voltage by 90 degrees. Is this clear? So if you draw this is a phasor diagram,
Yes, sir.
waveform. Okay, that's a wave. Here we have one more component. One more thing here we can write XL is directly proportional to L and XL is directly proportional to the frequency. Means more the inductance, more will be the reactance. More the frequency, more will be the reactance. Is that clear? So suppose if you are drawing a graph, such type of graph will be asked in the exam. Suppose this is XL and this is the frequency. It's a straight line. Understood now? If you're drawing a graph or plotting a graph for inductive reactance versus the frequency, what will happen? That will become XL is directly proportional to nu. Is that clear? So next one. So if both
Yes.
inductive reactance or capacitive reactance, both are measured in terms of ohms. Okay. So it is measured in both of them are measured in ohms. Now next one is what? Next one is here we have in for capacitor we have seen. So here we have XC is equal to what? 1 by omega c. This is said to be the capacitive reactance. In capacitive reactance, as the frequency increase, that means XC is directly inversely proportional to the frequency. If you are drawing the graph here, XC versus frequency, the graph is like this. This graph is important. This is not there in the book, but they are asking questions based on this one. How is the frequency related? I plot a vary. What they are saying, how does the question is how does the reactance vary, inductive reactance vary with the frequency? Then plot the graph. How does capacitive reactance vary with the frequency? Then you have to plot a graph. That is the question they are asking. But these two graphs you will not find in the test book. These two graphs are not there in the test book, but they are asking the question for that also. Like there will be ABC questions. One of them question is like this. Is that clear? So clear? Now.
So what did I could not hear you properly that time?
Now the thing is, the question is, how does inductive reactance vary with the frequency? How does capacitive reactance vary with the frequency? Such type of question they are asking in the exam. Understood now?
Okay, so
Yeah, but these graphs are not there in the test book.
okay, so
But you have to plot this graph in the exam. Okay. So maybe like ABC questions will be like ABC. No, in a question we have 3 parts. So one of the part is like this. So now, so what again? What will happen for one cycle? We will see that from A to
yes, sir.
from A to B. What will happen from A to B? Will let us see that.
Okay, sir.
Charges. A to B will charge. B to C will discharge. C to D will again charge in opposite direction. D to E will again discharge. Is that clear?
Okay, okay, so
A to B is charging, B to C is discharging, C to D is again charging, but in opposite direction. D to is again charging, D to is again discharging. That happens for one cycle. Coming to what will happen to the what you call energy absorbed. Here A to B energy is absorbed, B to C energy is released, C to D again energy is absorbed, D to E is again energy is released. Okay, or returned. Okay, so that thing will happen. Is it clear now? Is it clear all of you?
yes, sir.
Okay.
Yes, sir.
So we will directly go to now the next part, that is LCR in AC. Okay, LCR in AC. Okay. So AC voltage applied across LCR. This is the third part. Okay. Is this clear? So now directly we are going to put all these 3 components in AC in AC. Then we will see what will happen. What will be the output? Why do we study all these things? See, this type of things especially are used in electronic circuits. Okay, suppose you might have seen motherboard, TV motherboard or computer motherboard. On the TV motherboard or computer motherboard, there will be ICs, there will be capacitors, there will be resistors, there will be inductors. Okay,
Yes, sir.
boards and transistors. Many things will be there on the motherboard. You might have seen. If you open an old motherboard, which is spoiled one, you can from the computer or from the laptop or something, you can take it out and you can just, if you visit anywhere, you can see the boards. On that board, you will find all these things: resistors, capacitors, inductors, ICs, diodes, then transistors. Then you might find so many things. Okay, other than that, all the toroids also you will see, solenoids you will see, many things you will see on the motherboard. Okay. Now we will see what will happen. All these when all these 3 components are fitted on the when they're connected to an AC circuit. Is it clear now? Is this clear, sir?
Yes, so
Okay. So now we will start. Okay. So this is one of the important questions. Okay. Yeah, these are all capacitors. It's printed on this one. Yeah, this is it. No. Yeah, they are capacitors. They are capacitor. This is it. This is IC. Yeah. So this is an IC. Okay. This is IC. This one is IC. This is also IC. IC means integrated circuit. Okay. No, this is a modern one. The old one we use. Yeah, yeah. No, this is a new version. Yeah, this is a new version. I'm saying the old one, little old one. You will find now there are all these things are coming under the small ones now. Now they have miniatured everything. You cannot identify unless and until you read it. You won't identify that. Okay. So yeah, it is there. It will be there. Yeah, that is diode. Yeah, diodes. It will be there. Okay. I'll just show you. I used to have this one diodes, transistors, and all. I don't know. I lost that cover. I used to have all these components in with me. Okay. So with that. Okay. Now, so we will start with RLC circuit. Okay. Now, AC voltage applied across. AC voltage applied to a series LCR circuit. Applied to a series LCR circuit. Okay. AC voltage applied to a series LCR circuit. Now, what will happen? Series LCR circuit. So, what will happen now? I am going to connect a AC to what? There is a resistor here connected to a capacitor, then inductor. Okay, connected to a it is connected to capacitor and then it is connected to inductor. Okay, capacitor, resistor, and inductor. Okay, so this is the EMF. So what is the formula now? The formula here is V is equal to what? Vm sin omega. V is equal to Vm sin omega. This is the formula. We start with the formula. This much is the applied. Okay, now we have to compare voltage. This is the given voltage V. The voltage across resistor is what? IR. So we have to compare voltage with voltage. As I told you before also, we have to compare one voltage with the so we have to compare one voltage with another voltage. So V is equal to what? IR, and capacitor voltage is what? Capacitor voltage is Q by C. V is equal to Q by C. Okay, we have the formula. What is that? First formula is V is equal to IR. So we have C is equal to Q by V, implies V is equal to what? V is equal to Q by C. This is the formula for voltage. Okay, this is the formula for voltage, and the voltage across this one is what? V is equal to L into di by dt. Okay, so V is equal to what? V is equal to L into di by dt. Is this clear? So V is equal to Vm sin omega t. This is the input signal. The voltage across resistor is IR. The voltage across capacitor is Q by C. The voltage across inductor is L into di by dt. Okay, so we can add now. We can add all the physical quantities now. So what is that? V is equal to IR plus Q by C plus L into di by dt. Is that clear now? Is this clear, Mr. Arham and Arvind? If you are not understanding anything, please stop me and ask.
can you explain it again?
Now see,
Yes, sir, even I can get it.
we have three components now connected in an AC. Okay, we have
Yes, sir.
three components connected in an AC. Now, if you want to come as per the Kirchhoff second law, as per the Kirchhoff second law, you have voltage can be compared with the voltages. Voltage can be compared with the voltages. Okay, so E is equal to what? IR. So here what happens? The voltage here is IR. The voltage here is what? We know the formula, that is C is equal to Q by V, V is equal to Q by C. So we can take that Q by C into consideration. Similarly, the voltage across inductor is what? L into di by dt. So this voltage is equal to voltage of this plus voltage of this plus voltage of this. Is that clear now?
Yes, sir.
Is that clear, Mr. Abid?
Yes, sir.
Okay. Now, if you don't understand in any time, just stop me and ask me. Otherwise, write in the chat box. Okay. Now, the phasor diagram. What is the phasor diagram? Let us see. What is phi phase difference between the voltage and current? Okay. Phi is the what is phi? Phi is phase difference between voltage and current. Phase difference between voltage and current. Phi is phase difference between phi is the phase difference between voltage and current. Okay. Now, what is I? I is representing the phasor current. Okay, representing current. Phasor representing current. VL is the voltage across the inductor. I'll write all the terms now, one by one. I'll write all the terms one by one. Now, what happened now? Fitting there. What happened? One second. Now, man. So here we have. So what is VL? VL is voltage across inductor. I'll write here. So here, okay, this is a phasor diagram solution. Okay, first there are different ways of solving this. There are three parts. One is phasor diagram solution. There are two solutions: analytical solution and phasor diagram solution. So they can ask any one of them. They cannot ask two at one time. They'll ask either phasor diagram solution or analytical solution. So I'm going to draw the phasor diagram, then I'll explain you what is that. So we have the formula. What is that? I is equal to what? Im sin omega t. I is equal to Im sin omega t plus phi. This is the formula for current. Okay, what is Im? Im is the maximum current. Okay, this you studied in both the three circuits. Okay, and what is phi here? Phi is the phase difference between voltage and current. Phi is phase difference between phase difference between V and I. Okay, the voltage and current. Okay, phi is the phase difference between voltage and current. One second. No? No. So phi is the phase difference between voltage and current. Now here, what is VL? VL is voltage across inductor. Okay, here is voltage across inductor. Okay, VL is voltage across inductor. VC is what? Voltage across capacitor. Voltage across VL is voltage across capacitor. VR is what? Voltage across resistor. Okay, so we are three voltages. One is voltage across inductor, voltage across capacitor, and voltage across resistor. Okay, so V is the voltage of the source, capital V. It is voltage of the source. Is that clear? So we have VL, voltage across inductor, VC is voltage across capacitor, VR is voltage across resistor, and V is the voltage of the source. So VR is parallel to I here. So VR is parallel to I. There is no phase difference, right? What happens when you connect what happens when you connect a voltage across resistor? What will happen? Yes, sir. Arham and Abir. The first circuit what we discussed here.
So what was the question?
The question is when you connect a resistor across AC, what will happen? Will they in the phase or out of phase or leading or lagging? What will happen?
So they'll be leading.
Man, when the resistor is connected in an AC, what will happen, Apit?
Lag.
Just go back to the circuit and see what is exactly happening over there. Okay? Okay, excellent.
So it will be in phase.
Yes, ma'am. See here. What happens? Did you go through the circuit? What will happen when a resistor is connected in AC? What will happen, ma'am? Is the current is leading, lagging, or is it in phase with the given voltage? Just Abid and Arham. What do you think?
So it will be out of phase.
Huh?
So out of phase.
Why out of phase? You haven't seen the first diagram? Did you draw the first diagram in your notebook?
Yes. So
So look at the phasor diagram, how it is for resistor.
so it'll be in phase.
It is in phase, right? That means there is no angle. So that is why I wrote here. What did I write? VR is parallel to the current. Understood now? Now the second one is what? VC is pi by 2 behind. So voltage across. So voltage across the capacitor VC is what happens to VC? Is it leading or lagging? Lagging. VC will be leading or lagging? Yes. One is VC, one is VL. Who is leading here? Who is leading the current now? Okay.
जो मिल रहा था वो भी ठीक कर दिया
Okay.
अभी आप तरफ से
Okay. Thank you.
So what happened?
Yeah. Now there are some maintenance people. One second. Let me just give me one.